in today's lesson, we will be solving quadratic equations using the quadratic formula. In the last lesson, we solved quadratic equations using the factoring method. But what do we do when we are working with quadratic equations that cannot be factorable, which we worked with when we covered our factoring lessons, right? We saw that there were some quadratic equations that were unfactorable. So what do we do then? Well, another way to solve a quadratic equation is by using what is called the quadratic formula. Okay. So given a quadratic written in standard form, which recall is x squared plus bx plus c is equal to 0, where your a coefficient can't equal 0, the quadratic formula is written as x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's just break that down quickly. The x in the quadratic formula is the solution to the quadratic equation. Okay, so that's our solution to the quadratic equation. The a, b, and c are the a, b, and c values from the standard form of the quadratic. So when we're using our quadratic formula, we need to make sure that our equation is written in standard form. Okay, so your a, b, and c are from the standard form. And when we substitute those values into this formula, we calculate the solution or solutions to our quadratic equation. Note that the symbol plus or minus, or the plus on top of the minus sign, is read plus, plus, or minus, which indicates that there are two possible solutions in which you would add first the square root of b squared minus 4ac to the negative b and then divide by 2a, or you would subtract the square root of b squared minus 4ac from the negative b all over 2a. So you're applying two different operations separately. It's the plus and the minus. You can't do plus minus at the same time. Okay, so this is just to separate or differentiate the two different solutions that you get from adding the square root and then subtracting the square root. And again, make sure that your equation is in ax squared plus bx plus c equals 0 form, so standard form. Okay. One quick note that I want to put as an aside here is that when you're writing the formula, there's many different ways to confuse yourself. Okay, some students will write the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So notice that the b squared is the only term underneath the square root, and then you have the minus 4ac outside. Wrong. Okay, you need to make sure that the square root is over top of the b squared and the 4ac. Okay, another way that students write this equation to confuse themselves is they write x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So they will write the negative b plus or minus the square root of b squared minus 4ac, but only divide that square root part by 2a, leaving that negative b out, or not being divided by the 2a, which again is incorrect. When you evaluate this formula after substituting in your a, b, and c values, you need to evaluate the top part first and then divide all of that by 2a, not just part of the top part. Okay, so be careful when you are rewriting this formula. Okay, so let's try an example. In order to use the quadratic formula to solve an equation, we need to write it in standard form. And this is the same as if we were using the factoring method. So the first equation here is given as factorable, but it's not written in standard form. And when we're solving these equations for both the factoring method and the quadratic formula method, your first step should be to expand, simplify, and write in standard form. Right? Same step, first step for both methods. This, it looks like it's in factored form, but on the right side of the equation, it's not equal to 0, which means that we need to bring that -7 over to the other side of the equation and add it to the terms that we have on the left side. So that means that we're going to have to expand it out first and simplify. So we have x squared minus 5x plus 3x minus 15 plus 7, because I brought it over the equal sign, equals 0. Simplifying this on the left side, we have x squared minus 2x. Negative 15 plus 7 is equal to negative 8 equals 0. Next, we want to now factor this trinomial, and it's a simple trinomial. So we are going to use our factoring method. And when we factor this, we get x minus 4, x plus 2. That each of our factors equal to 0. So x minus 4 equals 0, and x plus 2 equals 0. And we solve for x for each of our equations. So x equals 4 and x equals -2 are our two solutions. So this is a recap of our factoring method. Fine, factorable. Can use the factoring method. And we want to try to use the factoring method for any equation that can be factored. But for those that are unfactorable, right? And I'm telling you this is unfactorable, but if you were to do this on your own, you would see that this can't be greatest common factored. This is a complex trinomial, so we're going to use guess and check or the decomposition method. Nope, we can't find any values that we can substitute into our binomials to get this trinomial. Not factorable. Okay, so we are going to apply our quadratic formula. Oh, how do we do that? For right now, as we are starting to learn how to apply the quadratic formula, write everything out, right? Organize your thinking. When we have our quadratic formula, we need to substitute in a, b, and c into the equation or the formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You guys will dream about this formula by the end of this lesson, hopefully. Well, what's our a, what's our b, and what's our c? Our a is equal to 9. The a is always the coefficient on the x squared term or the squared term, right? So even if we change the variable to y, the squared term always has coefficient a. B is the coefficient on your x term or your first degree term, right? So that's going to be -24. We always have to include the sign along with the actual number. And then C is your constant, right? So this is going to be 16. And again, I say, regardless of whether this is an x squared and x or a y squared and y or an a squared and an a, you still need to be able to identify your a, b, and c for the quadratic formula as the coefficient of your squared term, the coefficient of your first degree term, and the constant. Okay, so don't get confused with variables. Now that we have our A, B, and our C, we can substitute them into our formula. So that's going to give us -24, right? So the negative that is being multiplied to the B, let's think of it as a -1. So it's like saying -1 times B, and your B is -24. So it's -1 times -24 plus or minus the square root of b squared. So b is -24, and we're going to square that, minus 4 times a, which is 9, times 16, all over, right? Notice how my division line goes all the way across the top, 2 times a, which is 9. Okay, so that setup is important because after that, it's just strict evaluation, which we know how to do using BEDMAS. Okay, and you don't have to show every single step of your evaluation. You can do steps in one step of your solution. So you have -1 times -24. That's going to give us 24, plus or minus -24 squared is equal to 576 minus 4 times 9 times 16, which is equal to 576 all over 2 times 9, which is 18. And again, we evaluate. So we have 24 plus or minus 576 minus 576. Well, that's 0 over 18. So to evaluate the plus and the minus, we're going to write x equals 24 plus the square root of 0 is just 0 over 18, which is equal to 24 over 18, which is equal to 4 over 3 when we reduce, or x equals 24 minus 0 over 18, which again gives us 24 over 18, which equals 4 over 3. So our two solutions are 4 over 3 and 4 over 3. They're identical. So we would say that the solution to this quadratic equation is 4 over 3, right? So we're only going to write it one time, indicating that this equation only has one solution. Remember last time we said that a quadratic equation can have one solution, two solutions, or no solutions at all, right? In this case, there's one solution because the two solutions that we found were identical. Okay. So also note that when we do the quadratic formula, depending on how many steps you show, it could take up a lot of space. I'm writing big, but just make sure that you have enough space to show your work clearly. Let's try the next unfactorable problem. So I'm telling you again that this is not factorable. You could check it if you don't believe me. Try to factor it. But it is not factorable. So we're going to apply our quadratic formula. How do we do that? First step, make sure that your equation is in standard form. So we're going to move that -2 on the right side of our equation to the left side. 4x squared plus 3x plus 2 equals 0. And we're going to figure out what our a, b, and c values are in our equation. Well, a is 4, b is 3, and c is 2. Applying our quadratic formula, again, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And substituting in our values for a, b, and c, we get x equals -3, right? Because the negative is being multiplied to the b, or -1 is being multiplied to the b. -1 times 3 is -3, plus or minus the square root of 3 squared minus 4 times a, which is 4, times c, which is 2, all over 2 times 4. Okay, the setup is very important. Now we evaluate. -3 plus or minus the square root, the exponent first. So 9, 3 squared is 9, minus 4 times 4 is 16, times 2 is 32, all over 8. And again, I'm going to move my solution over so I don't go into the next question's solution area. So we have, and I'm going to write x here, x equals -3 plus or minus the square root of 9 minus 32. That's equal to -23 all over 8. Okay, so our two solutions are going to be either x equals -3 plus or minus the square root of -23 over 8, and x equals -3 minus, oops, I put plus or minus here. So this is going to be the plus one, minus the square root of -23 over 8. Okay, so how do we evaluate for each of these solutions? Well, we got to figure out what the square root of -23 is. So square root of -23, hold on. How do you take the square root of a negative number? Well, in grade 10, let's just say we don't. It's not that we can't, but we just don't do it, right? Taking the square root of a negative number gets us into another set of numbers called complex numbers, which we will not even touch, right? So you just need to know that when you take the square root of a negative number, you get a complex number, which is not a real number. So we cannot find a real root to or solution to this problem. Okay, so we would say no real roots. No real roots. Because we can't evaluate this with the knowledge that we have of real numbers. This is going to take us into complex numbers. So whenever you get a problem that simplifies in the quadratic formula with a negative underneath your square root, we just say no real roots. And we said that that was also a case. No solutions is also a case. So we stop. But you need to state it. You can't just write the -3 plus square root -23 over 8. You need to also identify that that means there's no real roots. D. Again, we need to make sure that this is in standard form. Simple rearranging by moving one term to the left side or moving all of our other terms to the right. We have x squared plus 6x minus 14 equals 0. Got to figure out what our a, b, and c are. A, b, c. Our a is a 1. Our b is 6. And our c is -14. Okay, let's plug these values into our quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So when we substitute in our values, we get x equals -6 plus or minus the square root of 6 squared, which is 36, minus 4 times 1 times -14, don't forget the sign, all over 2 times 1. Again, in our evaluation steps, we're going to simplify what's underneath the square root. So we have 36 plus, because -4 times 1 times -14 is going to give us a positive 56 or 52, sorry. Oh, 56 all over 2. And then let me move my work up here. So we have x equals -6 plus or minus 36 plus 56 is equal to 92 all over 2. So our first solution is going to be x equals -6 plus the square root of 92 all over 2. And our second solution is going to be x equals -6 minus the square root of 92 all over 2. And we can evaluate this two different ways, depending on what the question is asking you to do. You can either leave it as a radical, which you guys learned how to simplify, right? So I'm just going to put on the side here. Root 92 can be broken down into the square root of 4 times 23. And because we can square root 4 to give us a whole number, that's going to give us 2 root 23. So you can leave it as a rational expression. So -6 plus 2 root 23 divided by 2. And x equals -6 minus 2 root 23 over 2. Or we can evaluate this to give us a decimal value, right? So you're going to multiply the 2 times the root 23, add that to the -6, and then divide by 2, and that will round to 1.79. And I'm going to tell you guys to leave it to 2 decimal places, right, for your solutions if you are asked to represent it as a decimal. And then on the other side, -6 minus 2 root 23 over 2, when we evaluate that using our calculators, that's going to give us a -7.79. And again, round to 2 decimal places because these decimal values are non-terminating decimals. Okay, so our two solutions are going to be x equals 1 over 79 or 1.79 and x equals -7.79. Or leaving it as a rational expression, again, fraction, -6 plus 2 root 23 over 2, and x equals -6 minus 2 root 23 over 2. Okay, our last example. We have a quadratic, again, telling you that it's not factorable. You would have to check this. How would we use the quadratic formula to solve this? Well, our A, B, and our C are 8, 14, and -15. Make sure that you apply the sign in front of the term to the number. Okay, using our quadratic formula, x is equal to -b, so -14, plus or minus the square root of 14 squared minus 4 times 8 times -15 all over 2 times 8. Evaluating this, we get -14 plus or minus 14 squared is 196 minus 4 times 8 times -15. That's going to give us -480. But because we have negative and negative, that's going to simplify to a positive, right? Or you can think of it as -4 times 8 times -15. That gives us positive 480. That is another place where students make mistakes with the signs. Pay attention. The 4 that's being multiplied to your A and your C is considered negative. All over 2 times 8, which is 16. So x is equal to negative 14 plus or minus 196 plus 480 is equal to 676, all divided by 16. Let's move over, give us more space. So our two solutions is going to be x equals negative 14 plus the square root of 676, all divided by 16, and x equals negative 14 minus the square root of 76 all over 16. And we can evaluate. So the square root of 676 actually gives us a whole number. 676 is a perfect square. That's going to give us 26. So now we have negative 14 plus 26 all over 16. And same with the other side, or the other solution, negative 14 minus 26 all over 16. Again, evaluating these individually, we get negative 14 plus 26 is equal to 12 over 16, which, again, whenever your solution is a fraction, you need to make sure that you reduce it to its lowest form. We get 3 over 4. Okay. For the second solution, negative 14 minus 26 is negative 40 over 16. That simplifies to negative 5 over 2. So our two solutions are x equals 3 over 4 and x equals negative 5 over 2. That's it. Okay, the last thing that we are going to be looking at is the number of solutions for each. There is a pattern when using the quadratic formula to identify which quadratic equation has one solution, two solutions, or no real solutions. So just going back to our first our first example, the factorable one. How many solutions did that have? Well, that had two solutions. So A has two solutions. B had one solution. C had no solutions. Oops. D had two solutions, even though they were irrational, still two. And E also had two solutions. Okay, so A, D, and E had two solutions. B had one, and C had no. So no real solutions. So if you noticed the pattern when we were doing these questions, congratulations. If not, don't worry about it. The square root indicates how many solutions our quadratic is going to have. And that b squared minus 4ac underneath the square root in our quadratic formula is called the discriminant. So we use the discriminant to identify the number of roots or the type of root for each of our quadratic equations. If you're not specifically being asked to identify what those roots are, but you need to figure out how many roots there are. So if the discriminant b squared minus 4ac, or the value underneath the square root in the quadratic formula, is less than 0, so negative, which we saw in question C, right? It was a negative number, so we couldn't evaluate the square root. That means that there will be no real roots. If the value underneath the square root is equal to 0, as we saw in question B, there will be only one solution. because you're adding and subtracting 0, which is the exact same thing. And then if the value underneath the square root is positive, so greater than 0, there will be two different or distinct real roots, so two solutions. Okay, so from question C from before, without actually solving for the solutions, but just identifying how many solutions there are, we know that our A is equal to 1, our B is equal to 6, and our C is equal to negative 14 when we move it to the other side of the equation. So to solve or to figure out how many roots there are, we would just substitute into the b squared minus 4ac discriminant formula and figure out if the value is greater than 0, less than 0, or equal to 0. So we have 6 squared minus 4 times 1 times negative 14. 6 squared is 36. Negative 4 times 1 times negative 14 is equal to positive 56. Add those together, that is equal to 92, which is greater than 0, which means, so this implies that this equation will have two solutions. And that's how we use the discriminant. Next year, you will work a little more with discriminants. This is just like an introduction to discriminants. So that is how we solve quadratic equations using the quadratic formula. The homework is from section 4.5.4 in the textbook, page 292 to 293, number 1 to 3, all of them, and 5 all.